Faulting, in simple terms, is a difference in elevation at the joint, a transverse joint or a transverse crack. That's basically what it is. And the more faulting you have on a pavement, the rougher the ride. And it's also an indication of that your support layers are deteriorating. In the past, we used to make the assessment of faulting using a fault meter, a manual fault meter, which is a pretty tedious endeavor. If you imagine having to do that on a 1 mile section of pavement at each joint every 15 feet, it would take a long time, and it would expose the person doing the collection to the hazards of a roadway, and often you may have to close a lane to make such measurements. Measuring faulting using the new technology, it's done at highway speed, and we can get the data at every joint. It's done much faster than compared to the traditional method. It's a matter of minutes from the moment you start your profiler to the time you finish your survey. So we can do miles at a time in a fraction of a time that we used to use with the manual methods. Besides that, not only are we getting the faulting data, but we're also getting rutting and ride information from the same run. So the advantages are there. I mean, there's great advantages in terms of time savings and cost. And safety, we must not forget that aspect. You tend to get a much rougher ride when you have faulting. When you have traffic traveling on a pavement, when that load from the wheel is transferred from one slab to the other, it's putting a lot of dynamic loading and basically a lot of damage to your pavement. Imagine riding on a motorcycle or a bicycle over a pavement that has faulting. It would be a pretty rough ride, though it is an issue that it's best resolved when the faulting starts to get to the moderate to the severe level. It's usually in the longer it stays there unresolved, the problem tends to be exacerbated, and it needs a solution as quickly as possible before it gets any more serious problems with the base layers.